Today, shelf light. I'm going to go through the answers. If you have any questions, ask. For the first one, you needed to simplify, so combine your like terms. Then you should have gotten negative 13k plus 11. Number 2, that's going back to when we were solving literal equations. So getting w by itself. Subtract, well, one way to do this is to subtract this entire term 2l to the other side, divide everything by 2, and you would get that entire fraction p minus 2l. You also could have simplified this. If you put it as dividing by 2, dividing by 2, so that would become p over 2 minus l. Either of those was fine. Number 3, in order to combine like terms, you needed to distribute 3 times. And then be careful with your signs. So you ended up with a negative, 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 positive, and positive, negative. Combine your like terms. All your x's would have got you 1 positive x. And then your constants a negative 20. Number 4, it asked you to find the perimeter of this rectangle, and it gave you a length. The formula that was given to you in number 2 was actually the formula for perimeter. 2 times width, or plus 2 times width. So multiply both sides by 2, or you can add up each side. And you should have gotten 10y minus 10. And then for the last one, so you could think about that one as it equaled 1, but remember all whole numbers are really fractions. So you could make that a fraction and multiply. The other way you could have thought about that is taking this and just multiplying this entire side by 2. 2b minus 8 on the left would have canceled, just leaving 3. And then you want to multiply it on the right, kind of getting this exact same thing. So either or would have worked. And then solve for v, and you should have got, a fraction or decimal, 11 over 2 or 5.5. Questions on any of those? So before we get into our new notes for today, I wanted to mention a couple things. One is not really classroom, well, it's kind of classroom related, but not like me related. Apparently, there is a homeroom door decorating contest. So if any of you are creative and want to decorate the door before or after school, during class, I don't care, have at it. They just said no lights, the window must be visible. The winners will have breakfast with the leadership next week. So between now and Friday, if you guys want to decorate the door, not related to that. Remember that your calendar is always tentative. Right now, your test date on that is like the 25th, the 26th. That was before Dr. Haley said, well, in class, usually we don't test or do things during the week of homecoming. But Dr. Haley changed that. So we may rework some of these dates. I'm not sure. To switch the benchmark stuff and the test date. But I don't know yet. None of this unit 2B will be on marking period 1. So whether we test it before the end of marking period 1 doesn't really matter. all of that will be on marking period 2. So Khan Academies that are due coming up, the quizzes, the tests, all for this unit will be on marking period 2. The last grades in marking period 1 was that test and Khan Academies from last week. So when we take the benchmark, if you need to take the benchmark, that will make your grade go up. Going back and redoing Khan Academies will make your grade go back up. But other than that, your grade will stay as is once I put the test in. But be on the lookout because I'm not sure which one we're doing first, and I might get your opinion on whether we want to take the test first or the benchmark first. Closer to those dates. If that does change, I'll change it in Canvas and let you know in class. But just be on the lookout for that. Any questions on anything I just said? Alex? I don't think so. I don't think so. I'm assuming like Halloween.
I think it's supposed to be pink.
Okay, but yeah, the theme for the game is pink out.
I don't know. I can check.
I don't know. They honestly did not say. I don't know. Today we're going to start our new unit. This is like the last part of linear functions. Sure. This is only going to be 3 objectives because it's the last bit of linear functions that we need. Again, some of this may be review for you, some of it may be new to you. And you should have this within your papers. So starting off these notes, we're going to talk about parallel and perpendicular lines. Those may be familiar to you. When we talk about these definitions, parallel lines are lines that never intersect. So whichever way you're going, there's 2 lines that don't intersect at all. They'll never cross paths. Graphically, it's what that looks like. Algebraically, we know 2 lines are parallel if they have the same slope. So all the slope stuff we just did is not going away. We're going to continue to use that. And then perpendicular lines, definition, lines that intersect at a 90-degree angle. So basically they make like a perfect T, not an X, but a T. And then algebraically, we know 2 lines are perpendicular if they have negative reciprocal slopes. So if you're not sure what that is, reciprocals are fractions that are flipped. So like 3/4, the flip would be 4/3. The negative reciprocal is if I have a positive 3/4, the negative of that would be So flipped. There's one positive and one negative. Sign is switched. So really quickly, go through these examples. I forgot that 3/4 was so the flipped version of 3/4 would be 4/3. The negative reciprocal of that would be negative 4/3. If it's positive, we make it negative. If it's negative, we make it positive, but we're still flipping it. What would the negative reciprocal of 2 be? It would be negative, but it wouldn't be 2. And the negative reciprocal of negative 7/8. Negative reciprocal of 1. Negative 1. And then negative reciprocal of 0.
0.
Let's think about that. So 0 is really over 1. If I flip 1 over 0, what is that?
1.
By 0? What is that? A 0 slope. The negative reciprocal of 0 is going to be undefined. Think about those as your x lines and your y lines. We'll do one of these examples and then I'll say so these examples give you ordered pairs. You have to determine is the slope parallel, perpendicular, or neither. So find the slope of both. Remember that your slope to find your slope is that y2 minus y1 over x2 minus x1. And we're going to do that twice. One for AB and one for CD. So for AB, I went ahead and I labeled them just so I know which one to switch. And that would give me 6 minus 3 over 2 minus the negative 2. And then I'm going to do the same thing for CD. Minus 0 over 3 minus a negative 1. So parallel lines have the same slope, perpendicular lines have negative reciprocal slopes, and then neither, they would be different. Which are these? So you can either write out the word parallel, or you can use parallel lines. Questions on how we did that, how we found that? Really, it's just finding your slope, looking at the slope. Let's go on to 5. And do the same thing. Find the slope of AB, find the slope of CD, and we'll compare them. So I'm going to find the slope and then we'll simplify and talk about that. What would 9 over 0 be? Undefined. And 0 over 3? 0. So are these parallel, perpendicular, or neither?
Neither.
If I have a line that has a 0 slope and a line that has an undefined slope, is that going to make a perfect T?
Yeah.
Yes, those are perpendicular. These are also negative reciprocal. This is the sign for perpendicular lines, or upside down T. I think the one that'll probably trip you up the most is if you get 0 and undefined. Those are perpendicular. Even though the negative isn't there, they are still negative reciprocals. Another way you can kind of look at the slopes here, these x's are the same, and here these y's are the same. If you get something like that, they're going to be perpendicular. But if it were different, let's say these x's were the same, and then you got different order pair where x's were also the same, then it would be parallel, or vice versa. Do we have any questions on that one? Do you want to see one more example before I let you try some, or do you want to just try some? So the rest of those examples to number 8, go through those and try those for the remainder of class. I'll be around to check them. Number 2 was perpendicular. Number 3 was neither, however you say that. Number 4 was perpendicular. Questions on those 3? And then number 5, that's one we did. Number 6 was parallel. 7 was also parallel. And 8 was perpendicular. Questions on those 3? So tomorrow we're going to finish the equation part of that first page, and then go on to the second part of the parallel and perpendicular. So that's like writing equations when given parallel and perpendicular equations. Just so you have a heads up, you do have 2 Khan Academies on parallel and perpendicular lines Saturday, Friday. One I would hold off until after we do the rest of the notes tomorrow. The other one is basically what you did today. Well, I would hold off on that one until after tomorrow as well.